All right, welcome everybody. Welcome to the second session, and I'd like to call to the podium Kevin O'Donovan, the moderator for the session, and our Board of Advisory member. Kevin, the floor is yours.
Thank you, Lucian, and welcome everyone, and thank you for joining us here today for this IIoT Energy World session on mirroring success, digital twins and their strategic role in business resilience. Now, I'm delighted to be joined today by Arlen Nipper, the CTO and President of CirrusLink Solutions, Anne Imberson, the Area Vice President Digital at Nalco Water, an Ecolab company, and John Burton, CEO of Ursel Leo. Now, the topic of digital twins is something that's very close to my heart for folks that know me. But let's start with a small bit of housekeeping. For those of you joining us live, and we're all live here, so have a look around the actual tool that you're using. In the bottom right corner, you'll probably see a chat button. If you click on that, it opens a window, and you can use the chat to chat with other people on the conversation. And what we'd ask you for as well is put into the chat where you're joining us from today, because we normally get people from all over the globe. Now, beside that, you'll see a Q&A tab in the drop down. If you have a question for any of us in the panel going through today, please ask the question in the Q&A. We won't be watching in the chat so much. And we want to keep this as interactive as possible, so please keep the questions flying in, and we'll try and get as many of them answered as we go through. Keep it as interactive as possible. We'll be interactive and live here for probably about the next 55 minutes. And obviously, you know, these kind of events with IIoT World wouldn't be possible without the virtual conference sponsors. And specifically for this session, we'd like to thank CirrusLink Solutions. So Arlene and company, thank you very much. Now, with that, let's our panel. So what I'll do, I'm going to call on each person in turn, and they'll give a short introduction so you know where we're all coming from as we start getting into this topic. So, Arlene, if you'd like to introduce yourself, please.
Hello, good morning, good afternoon, everybody. Looking forward to this session. My name is Arlen Nipper, and I am the CTO of CirrusLink Solutions, and I've been doing industrial automation for the last 47 years. 25 years ago, I had the great opportunity to work with Dr. Andy Sanford Clark, and I was one of the co-inventors of the MQTT protocol specification. So thanks, and looking forward to it, Kevin.
Thanks, Arlen. And I know MQTT was a big topic in the last session. So with that, Anne, for folks that don't know you.
Yes, hi, I'm Anne Imberson, the Area Vice President of Digital for Nalco Water. And really, you know, throughout my career, I've had connections in the digital space, but getting back into the core of the operations and how digital can impact the OT space. So I'm excited to hear what my colleagues and friends have to say around digital twin and how we're all moving it forward today.
Thanks, Anne. And John, many folks will know you, but for folks that may not.
Yes, hi, good morning everyone, good afternoon. John Burton, I'm the CEO and co-founder of Ursel Leo. We've actually been creating digital twins since about 2019. Last year, we partnered up very heavily with NVIDIA. So at this stage, our digital twins are delivered using NVIDIA graphic engines, NVIDIA tools, and I will actually be presenting on the topic at NVIDIA's GTC conference next week.
Ah, yeah, there's been so many developments when it comes to digital twins over the past, many decades, and certainly in the last couple of years. And I suppose before we set out here, you know, the topic of the conversation today is around digital twins and their role in business resilience. So we're going to start by kind of defining what we all mean by digital twins. So Arlen, if I may, when I say digital twin, how do you define digital twin?
Well, from my world and with our customer base, really a digital twin is the actual process variables from a machine. Whether it's a pump in an oil well, whether it's a stamping machine in an automotive protection line, it's the machines like the PLCs behind me that are providing the process variables. Then it's our job as OT engineers, if you will, to build the digital twin that properly takes those process variables and gets them into the enterprise. So for the last 5 or 6 years, we've been very focused on providing that single source of truth from the factory, from the oil well, from the solar panel, up into the enterprise.
And Anne, if I may, from your perspective in your company, how do you look at a digital twin?
Somewhat similar, really just the model of the operations, real-time ability to model and drive efficiency and see ways that we can run simulations in real time to provide advanced insights. However, I will say, with digital twin and a lot of other technology and digital lingo, so many people have varying definitions. So I find it really important when we're working with our internal teams as well as our customers, that it's really important to have that dialogue to really unpack what challenge and or solution we're looking to embed, because a lot of times people have an opinion of what a digital twin is and it doesn't always match what everybody else is thinking. So I think it's really important to kind of unpack that translation on expectations.
No, I agreed. And you mentioned simulation. I know we'll come back to that later. And John, from your perspective, you mentioned you're working with NVIDIA, you have GTC next week. How do you see a digital twin?
I think all of the above. So I think Arlen's exactly right that it's a set of process variables that define what's going on. The bit that we add is we add a visualization layer, so an actual 3D model of whatever it is, and then a whole bunch of visual clues about what's going on. So really, I agree with everything, but the additional piece we're putting in is some visualization, very useful for simulation if we're going to get into that topic, because there's a very visual way of seeing what's going on when you start simulating events.
No, I agreed. And we'll certainly cover a lot of those topics and probably add one more. And I've seen a question come in already was going, what's the difference between the metaverse and a digital twin? We'll get there at the end. Now, the second kind of key topic of what we're discussing is business resilience. And, in the last 3 years, we've seen a lot of interesting things. There's one word happen in the world in terms of how resilient our economies, our businesses are. So let me start with Anne. When you talk about business resilience in your company, what are you looking for?
Really the ability to adapt and change to, as the world continues to be ever changing and, our processes are set. However, things continue to evolve, how we can, use the digital resilience to reduce our risk, drive continuity, and adapt to the environment, which I think technology and especially digital twins really help mitigate some of the risks there by allowing things to be modeled and simulated in real time to drive efficiency gains for our operations.
So if I may, it's just kind of efficiency gains, and then through simulation, in some ways doing the what if scenario planning, that if this happens, how do I get around it or whatever.
Exactly.
Alrighty. And John, if I may, from your perspective, business resilience in the world you live in?
So I think one of the great uses of digital twins is being able to access data, and there's a lot of data associated with facilities. There's maintenance records, there's asset information. Being able to use a digital twin to say, okay, I'm going to click on this thing that's throwing a lot of alerts, and I'm going to see all the maintenance history, I'm going to see the asset information, I'm going to see all the documentation. For us, that's really making some efficiencies gains when you're trying to maintain and operate a facility.
And Arlen, from your perspective, in terms of business resilience, when you work with your customers?
Well, really, it comes down to how accurately am I representing my factory? And we go through this all the time, is that, I've got a factory, it's Thursday, March 14th at 9:10 a.m. in the morning. Is the data that's going to my business actually representing what's on the factory floor? So, I call that the serendipitous nature of data, in that if we aren't providing a digital twin from the edge, from OT into the cloud, then we're always going to be out of sync. So from a business resilience standpoint, we're working very hard with this whole concept of the unified namespace to be able to make sure that our equipment in the field is providing that digital twin accurately in real time.
Alrighty. Now, I suppose we had a chat last week when we were going through some of this, and I suppose the challenge is in the next 50 minutes or so, we could probably talk for the next 50 days. There is so much to cover when it comes to digital twin. But we've kind of level set it on, well, what we see a digital twin is. We look at what the business resiliency are. You know, I'm a technology guy, and as cool as technology is, I very rarely find a company that's going, we're just spending lots of money on this technology because it's cool. They want to have some business value. They have a business reason for doing it. So John, if I may come to you, in the work you do, what business value are they trying to get that they then go, okay, I'm looking at digital twins to help me with this?
So I think we've touched on a couple. So definitely simulation is one of them. The ability to actually create a facility before they've built it, or reconfigure a facility before they've actually moved everything around, and simulate the operation and actually see what happens. So that's definitely one value. I'll go back to the sort of just access to information. You know, one of the issues you'll find in a large facility is just people trying to find data on what's going on. There's real-time data coming in. That's, you know, and that's kind of Ireland's world. But there's lots of other data sources they're going to need to access, and a digital twin can really drive efficiencies there. So there's a couple of different ones.
Alrighty. And Arlen, from your point of view, you know, again, you spoke about getting the process data, one version of the truth. What kind of business value are folks looking for? Why are they doing this?
Well, a lot, you know, we've got customers across the spectrum, from oil and gas to energy to manufacturing. If I look in a large, you know, when a ramp up has been in manufacturing, and it's all about OEE. It's about what is the availability of their equipment. And we're literally starting to see this concept of OEE trickle down to the other markets, into the oil and gas sector, into the energy sector. So really it's finding that efficiency of, my line went down. Well, why did it go down? And if I've got a digital twin and that data is being brought up, like John said, and it is definable, it's got context to it. So we've got to look at, really, my point is, without context and without proper representation, data lakes turn into data swamps, and we don't get to actually take advantage of that information.
Data swamps, we'll come back to that one, because data is key in all of this, right? You can have as cool a technology as you want, but poor data in, poor data out.
Right.
And
we've got a lot of swamps out there right now.
Oh, they're growing.
Yep.
Yeah, it's not a lack of data. It's good data. And if I may come to you in terms of, from your side, how would you invest in this, in digital twins?
Really, the ability to have that contextualization, you know, in the heavy industries we work in, you know, everybody has worked through driving efficiencies, but it's really being able to partner expertise with technology, kind of the people and the robots, if you will, coming together, because, you know, humans can only see and interpret so much so fast, and the ability to utilize digital twins and be able to see more of this information churned in real time to get to those valuable insights. But I do think it's hugely valuable that you have an imperative to have that expert understanding of both the operations, and, like with the work that we do in the water space, the utilities sometimes get overlooked, and the impact that they have on the broader operations, and looking beyond a single unit operations, and how the impact can be felt throughout the full facility.
Now, before we start diving into the role data has to play in this, IIoT, you know, a lot of topics we've been talking about for years, right, when we go back to digitalization. But there's one question here that's just popped up from Alper, and it's, what's the difference between a simulator and a digital twin? Now, I'd have my answer, but anybody want to take a stab at that? The difference between a simulator and a digital twin?
Yes, so a simulator is designed to do one thing. It's designed to simulate. A digital twin is something that can visualize simulations, which is typically not I mean, it often has a physics engine, and but the inputs to what happens come from somewhere else. Within a digital twin's also an operational product. It's also a way to manage all the data in the facility. So it goes way beyond just a simulator. It's a simulator plus a bunch of other stuff.
Any other comments? Or
I mean, I would concur with John. I would just add, the one kind of the biggest differentiator that I see is, that digital twin is real time in process, where a lot of times a soil simulator is more for development or R&D versus the actual current conditions.
Yeah,
Agreed.
I suppose my own 2 cents would be the simulation capabilities that you do in a digital twin is the same as what you would do in a simulator. But in the world I grew up in, as you say, a simulator was kind of a silo application. It was like, here's what we're thinking of building, or here's what we think we did build. And it was static. It wasn't getting fed with that real-time information from the real world, where I could do real-world simulations, because it's keeping up to date. That one version of the truth, as Arlen mentioned and you mentioned, in terms of what's going on in my water network, what's going on in the grid today. Give me that IIoT data, and then I can do simulations based on what's happening today, right now, not some theoretical point in the past or whatever.
Yeah, a lot of our customers, especially in oil and gas, I mean, we start with the basis of a real digital twin. So I've got a real pipeline, I've got real booster stations, I've got real centrifugal pumps, I have suction pressure, I have discharge pressure, and this is my pipeline running at 2000 PSI. And now I can take that entire physical of my digital twins and pull that over into simulation and say, okay, what would happen if I'm running at 2010 PSI? Is it going to cause my energy to spike, or am I actually going to get more efficiencies out of that? So I would say very few of my customers start with the simulation and go into the physical. It's more taking what they see for real and then feeding that back into a what if simulation.
Now, if I may, taking that what they see back into the simulation, we kind of go back to, well, you need to have sensors. You need to have something recording the data out at the edge, practically right across any piece of infrastructure. And when we start talking about IT-OT convergence, some folks listening will say, God, we've been talking about this for years, and we're still not done. And then my personal opinion, we'll never be done, because we'll always find something new to instrument or something else at the edge. But if I may, I suppose, in terms of, well, where are we today in 2024 with IT and OT? And Arlen, in terms of the work you do, what's different, what's easier, what's harder, what's the same? Getting that data back in real time to get that one version of the truth.
Well, from my standpoint, it really has kind of exploded. And largely a lot of people are using MQTT in this space. And with MQTT, you get to efficiently publish, very granular data. Then the industry as a whole has taken this and they've called it the unified namespace. And within the unified namespace, now I can start representing process variables and from process variables. So the sensor's behind me. I've got a 4 to 20 milliamp sensor, and our analog to digital converters. So in 5 years ago, that would have been a value of 1023. Well, is that 1023 gallons? Is it degrees? What's the engineering units? So we've gotten to the point now where we're going to the next level. Yes, that is an analog value, but here's the engineering high, here's the engineering low, here's the deadband. That's all the contextual data, so that when I go into my digital twin, I know that 4 to 20 milliamp transmitter is on this pump, on this pipeline, and this is its actual value. So we're leveraging IT for that. We're bringing IT technology down into the OT space, because you could argue that MQTT is an enterprise service bus for industrial.
That's one angle. That's true. And John, if I may, again, you're visualizing, and I'd be familiar with a lot of the excellent work that NVIDIA are doing with Omniverse and USD and. But again, where does IT/OT, the data, you know, the raw good data coming in from the sensors, where does that play into all this?
Yeah, so we're kind of a little further upstream than Arlen is. So we really start when somebody starts feeding us an MQTT feed. We're not spending a lot of time trying to make sure that data is accurate or normalized. I mean, you know, that's downstream from us. So once that MQTT data comes in, then our focus is very much on how do you integrate that with IT systems from a security point of view, you know, using REST APIs, data normalization from pulling in data directly from cloud systems rather than, you know, your MQTT data, you might have a REST API data stream as well. So our focus is all on the cloud engineering and the data visualization. But when you get into IT/OT, it's security, it's REST APIs, it's how do you integrate with all these IT systems that are going to be in the facility.
And from your perspective, obviously you've got a lot of OT technology deployed across your networks. How do you see that role in what you're doing?
Yeah, I think that the integration is key. Within the heavy industries, having data isn't the problem. And I think Arlen kind of alluded to that with the swamp data, but, you know, having the ability to contextualize and even identify where we may be missing data, and going in and putting additional sensors or putting additional IoT devices to collect that, I think is important, because by using digital twins and advanced technology to run analytics to be able to provide these insights, being able to have the right integration of the right data points at the right time is what really is allowing those insights to be derived and provide information directly to operators to make real-time changes to drive value.
Yeah, and to that point, Kevin, I think one of the things that's really starting to emerge as IT start to figure this out. So again, going back to the data swamp, analogy, is that now we started seeing Amazon, Microsoft, Google Cloud Platform, everybody go, oh, okay, we've got a digital twin. And they tried to cubbyhole us into what they thought a digital twin was. And I think we've moved beyond that, because a digital twin is only as valuable as how you're using it in your business. So we've got to have the ability to create digital twins the way the customer wants the digital twin, not the way that Amazon or Microsoft thought a digital twin should look like. And I think with that realization, we're moving to having tooling so that by the time John gets it, it is contextualized for the business case that we're trying to apply that for.
No, good point. When people say to me, define a digital twin, my kind of standard answer is, well, it's a digital representation of a physical system that either exists or that you might build. Now, that's a very broad definition. You could turn around and say an SAP system is a digital twin of some of your business processes, which it is. It's not very graphical, no disrespect to SAP, but it's a digital representation of what's going on today. But then you start getting, we put in more sensors, we get more data. And there's a question here from David, and I'm going to take this one for you guys now. When as I've grown up in this industry the last couple of decades, there was a time where, well, we didn't have sensors in the grid. We didn't have sensors in substations. We didn't have smart meters. Suddenly we started putting them out, and we were like, oh, we have to get all the data back to the cloud. And then we started doing that. And in some ways, we ended up with the data swamp. I have loads of data, just don't know what to do with it. Or I don't trust it. I'm not sure if it's good data. So there's a question here from David. Where do you see the utility of fog and edge-based systems in parsing digital twin data to avoid those digital swamps? And correct me if I'm wrong, David, what I'm expecting here is, rather than sending every piece of data from the edge back to somewhere in the big digital twin in the sky, maybe you need to do some local processing, edge devices, substate, whatever. Thoughts on that, Arlen? Does everything go back, or is it you just send back what you need?
No, edge is critical in contextualizing this data. To my point is that when we're at the edge, that's where the engineers know this is a 4 to 20 milliamp transmitter. This is a thermocouple. This is a LoRaWAN sensor. This is a PLC register value. But then we've got to contextualize that. And to your point, one of my favorite pet peeves is that, to your point, we have enumerations. So we get a value from a PLC. Like I'll give you an example: a motor operated valve. It's got, limit switch open on open, limit switch closed on closed. If we send those back from a business standpoint, is the valve open or is it closed? We don't know. So we take that enumeration from those PLCs, from those sensors, and at the edge, we can contextualize that to the point where when the valve status comes into John's simulation, it says open, in transit, closed, regardless of which brand of motor operated valve it is. And that goes across the board in using edge compute to get that contextualization, to provide that single source of truth for the digital twin upstream.
And if I may, in your environment, do you look at consolidating data out at certain parts of your architecture out at the edge, or does everything come back into the big cloud in the sky?
I agree. I think the edge is imperative for not only what Arlen said around the contextualization, but just sending every raw data point back for the sake of sending a data point back can become expensive from a data feed. But at the same time, I think it's also important to see who is looking at what data and where, because really having, I don't think it's a one-stop shop for understanding it. And Arlen mentioned the OT engineers and the engineers on site, they understand kind of where that data is coming into the edge, but then that contextualization and taking it up. And a lot of times there may not, depending on what you're looking at, and some of the stuff that we're doing with the water and energy systems, data doesn't always make significant changes in short order. And so there may not be a reason to send all of those data points that are being captured every second. We may only need to send them once an hour, once a shift, depending on where that change would come from, and understand what calculations need to be deployed.
And John, if I may come to you, when people would say, well, we want to visualize what's going on, there's too much data coming at us, we need to be able to comprehend what's going on to make sense out of it. How do you look at that? Say, is it like, give me all the data and then we'll figure out what to show you, or does it need to be parsed out of the edge? Excuse me.
Yeah, we don't do a lot on the edge, so I'm not an expert in it, but certainly there's certain things you wouldn't want to send to the cloud. I mean, if something's vibrating and you're measuring vibration, you don't send every reading. You kind of look at FFTs, fast Fourier transforms, and use that to get the data. In terms of our world, though, once the data is coming to us, which is someone else's, their decision to what they send to us, we start looking at things like alerts density. So if lots of machines are throwing alerts, and that's very often the case, we've got thousands of sensors. Let's make the one that's throwing the most alerts glow red, so it's very obvious that's the one that needs the most attention. So it's those sorts of visualizations. Energy usage is another one, looking at buildings and where there's 30 air handlers in the building and one of them is using way more energy than the others. Again, we can easily visualize that. Quite hard to get that data out of just numbers, but once you put visuals on top of it, it makes it a lot more digestible.
Alrighty, the questions are flying in here, and I'm seeing people from obviously various parts of the US, Portugal, Texas, India, Sweden, UAE, Israel, Italy, Nigeria, the Netherlands, Estonia, Finland, Indiana, US. So right, there's a good few people on, and there's a lot of questions coming in. So right. So we spoke about simulation, and if I may, I suppose what I would see when we talk about, what do you call it, fog or edge computing, if you look at the advancements in the compute power and the storage capacity in smaller and smaller devices that 10 years ago you needed a rack server to stick somewhere to do edge computing. Now you have tiny devices that can do an awful lot of processing and a lot of almost simulation itself out at the end to go do predictive maintenance. whatever, right? Even look at the smart meters from the likes of Itron today. You can drop applications onto them to do all sorts of stuff. So we're seeing a lot more of that as well. Simulation. So if I may, many people that I would come across would say, a digital twin is great because it's a nice, cool, animated representation of what's going on. It helps me see the data. And I go, yeah, that is a step forward rather than the wire diagrams and whatever, something flashing red. So I get a lot more visual representation. You start doing reality capture. You start doing taking drone footage, satellite. You can build all sorts of what's going on. What does that look like out there? But simulation to me is key. So if I may, when you look at being able to simulate things, and if I may, any examples of what you would, the data that comes in, your digital twin, what would you simulate to kind of help you in your business resilience or your day-to-day jobs?
I think one of the things that we're looking at with the digital twin that we have in place for climate intelligence to drive energy efficiency and improve water, really to understand the different variables and the impact that they have on each other, as well as the changes that an operator truly can make in a given time and what that would yield. So looking at how different data points, different insights can correlate and visualize out to be able to see and make impactful changes.
And Arlen, from your perspective, in terms of in your world, people using simulation, what kind of simulations are they doing, or what are they looking for?
Well, again, I mentioned it before in the oil and gas industry, is being able to simulate their processes based on, what they had seen previously, and then being able to replay that and say, should we change a set point here? What is operating on that? The other thing is in factories is to be able to simulate their production line. Again, the crucial thing there is OEE. Improve your OEE by 5 or 10% can represent millions and millions of dollars. So how can I take this manufacturing line that, it's running at 80% OEE? Well, let's take that out and then let's run some simulations on that and see where could we optimize. Is it this work cell? Do we need to add another work cell in there? What optimizations can we make for those particular processes? Now, everybody that's on here are probably from a different industry. So we've got everything from food and beverage to oil and gas to energy to pharmaceutical to, you name it. And so everybody here, we're thinking from the lowest common denominator, again, in my world, is the sensors, and then working our way up from there. So, we start with sensors. Let's contextualize that. Let's get it into a model. Let's get a single source of truth into the cloud. And now let's work on that representation with the technologies like John does.
Alrighty. So there's a question that's popped in here, and I mentioned it earlier as well, in terms of the digital twin, in terms of the simulation, the visualization, and all the cool stuff you can do. Obviously, you have to get the data back from the real world systems, OT, IT. What's the role of having good data? Because maybe I've cleaned up the swamp, so it's not as swampy, but do I trust the data? How do you guys go around and chat to customers about to say, well, how do we know my data is good? Am I making the right decisions? Is the simulator working off good data? John, I'll come to you if I may, in terms of you're visualizing this. Is it something you look to your customers, say, do you ask them to prove that the data is good, or are there tips and tricks as to how to, sanitize the data?
The only thing we really do is we normalize data. So typically data coming from different sources will be, even sensor data can be in different JSON formats, and we normalize that into a single type of data. But yeah, what's being sent to us, we're not checking that the pressure coming off valve 73 is really the pressure coming off valve 73. That's when you have to be somebody down on the factory floor at edge computing who's making sure that the numbers coming out are the real numbers. What's the role in good data? Yeah, obviously, if you have poor data, you have garbage in, garbage out. It's been true since computers were invented.
Yeah, this is true.
Yep.
Any other comments in terms of, how do you look to trust your data?
Well, again, I think it goes back to your point. A lot of that data validation, making sure that our 4 to 20 milliamp is operating correctly, making sure that our PLC is operating correctly, that has to be done at the edge. So that's where your edge platforms come into play. So that by the time I am publishing data up to the cloud applications, again, I do know that that is valid data going up. So that the days, again, to Ann's point, I've got 1,000 sensors, so every 1 second I'm going to publish up 1,000 analog readings. That's gone away. That literally, some people are still doing it, but for all practical purposes, now we're seeing people publish report by exception using MQTT. So if the pressure hasn't changed, I don't just keep publishing it, right? And then having enough edge compute to make sure that that data that is coming up has been validated at the field level. Or, to John's point, raise an alarm. Say, hey, we know these data points are bad. Let's raise an alarm and say somebody needs to go look at those.
Agreed. Again, in my day, we saw a lot of people going, well, we'd love to do a lot of edge computing, but whatever, the silicon technology wasn't there, it was too expensive, cost too much power, yada, yada. So it's basically, I just grab the data, I use a very, as cheap as I can, communications thing, and I'll fire it up the line. Now with more compute headroom in tiny devices, as you say, I can do some sanity checking. I'm getting the data off this pressure. This is way out of whack. And is this just bad data, or is it an alarm? So you can do a lot of that sanity checking, and I think that's where grid edge starts coming into its own a lot more.
And if I could add to that too, I think a lot of times we overlook the importance of the data mapping and getting the right folks in the room to do the mapping, because what an IT person may think something is completely incorrect. And so I think it's really important that we bring all the right people together and don't overlook the importance of the mapping exercise. And sometimes that can be hard, sometimes it can be super simple, but I do think it's something not to be skipped.
No, great point. I remember a project a good few years ago where, again, a lot of data coming back, lots of control room screens flashing red in all directions. And once they dug into it, the chap that had been working in that hydropower plant for the last 20 years went like, no, that's not the problem. The problem is this over here. And I go fix that, and all the alarms will do it. So it's that institutional knowledge, again, joining the dots and being able to visualize what the real problem is. And sometimes just looking at the data doesn't give us that. So we'll come back to the role of people, because technology is the easy bit. Us people are still needed. If I may, there's an interesting question here as well. So I'll just throw this open to the floor. Sorry, scrolling down. This is from Rolf. How do you secure the data you're collecting? Are people encrypting this? Is it all inside the firewall? What do you guys see? John, in your, obviously you get the data in, but you're putting it in the NVIDIA's cloud or someone's cloud. How is it all secured?
Yeah, so that's a pretty broad question. I mean, there's a lot of different techniques. Encrypting the data to put it in a database is one of them. We have customers who want to operate on premise, so they want to take everything we've done in the cloud and put it actually on premise, so it's secured at the building level. And then you get into the whole security tokens and logins and how servers communicate with each other, and how you keep connections secure through login. So there's a huge range of security techniques for securing everything from usernames through to sensor data.
And if I may, I know, let's say in North America with NERC-CIP, not all data has to be secured the same way as every piece of data. There are certain high-risk assets, and you might have ultra secure protocols and encryption for that data. For smart meter data, maybe not as much, right? So that it depends on the risk assessment and your compliance with whatever the rules and regulations are as well. So it's not that we have to have quantum resilient everything for all the data right now. Not yet.
Well, and that in large part, that is the world that we live in. It's brownfield versus where do we live today. So again, pointing to the equipment behind me, we still have a lot of equipment that it's RS-232 Modbus, right?
Mhm.
So if I know Modbus, I can get in. So again, we're back to edge computing and technologies like MQTT, which sit on top of TCP. It's interesting. In 1999, when Andy and I invented MQTT, TCP/IP was not the prevalent transport. It was DECnet.
Yeah.
DECnet ruled the world, right? And so now we got lucky with MQTT. TCP/IP emerged as a standard that we can utilize. And from edge, that means that's why a lot of people are using MQTT, is that we don't have to have any ports open, and we can use the latest TCP/IP like TLS and things like that to secure that data. So from an edge compute standpoint, if we're publishing data into the cloud using MQTT, I can go scan that device at the edge. I can't even get in because there are no ports open. So that's really one of the advantages of why MQTT is being utilized for the ingestion of real-time data. But then after that, it's how well the customer manages his TLS certificates, what are his IT rules on how TCP/IP is protected. But at least we're moving to the point where you're leveraging TCP/IP security across your entire, from edge to cloud.
Alrighty. Yeah, there's a couple of more questions around security. How do you trust the data? Like, we'll take those probably offline, because I know Lucien and the IIoT world have an entire cybersecurity day, and again, you're only scratching the surface with that, because how do I trust the data came from where it's supposed to come from? And there are the good news is there are technologies to do all this. The rational news is that you need to figure out where you need to apply that for the risk reward. Couple of questions here. We've about 20 minutes, less than about 15 minutes left. Good question here. I'll throw out to the folks. I'm trying to scroll past because there's too many questions. And it was, where do we see digital twins being used most today? Is there a particular use case? Is it in, excuse me, I'm picking on the wrong one. Is it in asset management? Is it in simulation? Is it in what? We're coming at this from all different worlds, but if I may, and digital twins, where do you see it in the industry today being used most?
I mean, I think I see a lot of digital twins, and this almost goes back to the earlier comment around the metaverse, being used from a training and learning perspective. Although I think we're really moving into being able to leverage them more. And some of it, I think, is just a comfort level on that trust factor, to where it's moving towards improving asset reliability and, maintenance and operational efficiency. But I think by and large, more people have moved, with some of the energy companies using it for training, because I know, in my previous world, we had a digital twin or metaverse, whatever you want to call it, but of a nuclear power plant. And we're able to do different simulations for emergency situations that you could never do in real life. And, to do it on paper is one thing, but to actually put somebody in that situation where they can actually go in and use a digital twin or the metaverse to make those changes, I think is, really impactful. But, I think where the real value and where the real rubber is going to meet the road is, what we're starting to see now, where it's actually in the operational environment, making recommendations for real-time changes to drive that asset efficiency, asset utilization, and operational efficiencies.
Arlen, from your perspective, where do you see it most used or popping up?
I would, again, across our industries, if you look across, there's all kinds of maturity cycles. So I could say manufacturing, but then there are a lot of manufacturing plants that don't even know what their machines are doing. I could say it's in oil and gas. I could say it's in food and beverage. I could say it was in every industry, but yet it's not. So we have pockets of where people are really getting it. I think they're taking digital twin technology. They're starting to lay things like LLM on top of that. So they're actually talking to their processes. We have customers that are doing large language model training today on their digital twin coming into their coming from operations into their cloud computing platform.
John, any from your side?
Yes, actually, quite a few industries at this point. Definitely manufacturing, definitely smart buildings, definitely water utilities. We do quite a bit of business, especially in Europe, in that space. And then in terms of the functionality that people are using it for, I mean, the whole point of a digital twin is it's a model of a real thing. So anything you can do to the real thing, you can do. The digital twin can emulate, and it can do a bunch more stuff because you can do simulations on digital twins that you couldn't possibly do, in a real world environment. So yeah, then you get into everything from training through simulation, through real-time operation, through maintenance. Any one of those disciplines can be touched by a digital twin at this point.
Mm-hmm. One of my personal opinions on this would be, so over the years we've seen, to Anne's point, there is clear business benefit for doing some training with AR or VR or whatever, right? It's proven and proven. I suppose one of the features we would have is that somebody a couple of years ago, they would go and take a snapshot of what a facility looked like, reality capture, LiDAR scans or whatever. They'd make they'd make the training module, if you like, in VR or AR with that. And sometimes people would say, by the time you deliver that, we've changed something in the plant. And you have to go back and create it again. And it's kind of dated or whatever. And, Arlen, you mentioned it at the start, where we're headed is that you're getting real-time data into this digital twin. And with what NVIDIA and many others are doing, and, many companies will say, do you have a digital twin? We have loads of digital twins. We have different digital twins in different silos. Now we're starting to can we merge those together with something like Omniverse or Bentley's iTwin and the ability to be able to go off and almost create the new training on Monday morning by hitting return, and it gives you a training on what was the state of the building looked like on Friday evening. Now that's not all there yet, but that's where we're headed. I think that's going to be a huge step forward as well. Alrighty, where are we? We're 48, so we have a couple of minutes left. Folks, we are not going to be able to get to all the questions. We will be following up offline on these. You'll see some published work as well on IIoT World following this on some of these. There was a question, where do digital twins and IoT mitigate climate risk? And you mentioned some of that in terms of how you do simulations about the what if. I know many electricity companies are now starting to do, well, what if a snowstorm takes out that transmission line? Where do we get the power from? How do I reroute? So there's a lot of, and they've been doing this for years, right? Just the tools are getting better, they're getting better visualization. So we're seeing a lot of that. There's an interesting question there on the, what's the best open source digital twin? Depends on what you mean by a digital twin. So it's complicated. Right, so we've got about 7 or 8 minutes left. Let me do this. If you all have a crystal ball, you're all looking into the future. John, if I may, where do you see us headed with digital twins, building digital twins for more business resilience? Where do you think we're going over the next 2 to 3 years?
So some of the biggest issues I see is, it's great to say we're going to have all our asset data in one place. We're going to have all the information we need at our fingertips. Collecting that data and cleaning it and getting it into the system, and then using things like large language models, generative AI to query it. We're pretty close to that already. I mean, that technology has only been out there 18 months, but it's pretty easy to get hold of and use at this stage. But I definitely think getting into those sort of things where when will pump 7 next need maintenance can just be typed in, and the answer comes up, and the camera and the digital twin zooms to pump 7 and shows you a bunch of information and the maintenance records and the asset information, and it's almost under, you're not having to even, you're just typing in real world questions and getting that sort of contextual information back. I think is not that far away. It's not that science fiction-y.
The control room of the future. And Arlen, if I may, where do you see us in the next 2 to 3 years?
Well, I'm already starting to see it. We're going to get to the point where, we're going to get out of the mentality that we had. I got into the controls in 1980-ish timeframe, and to a large extent, we're still doing equipment with register values, with protocols, the way that we did in 1980. We're slowly getting to the point where equipment is just going to publish information that we're interested in. It's going to contextually know what it needs to publish and when it needs to publish it. That, using technologies like the unified namespace, will let us create the models, and that let us take into data cloud platforms like Snowflake. Once I've got into a data cloud platform like Snowflake, I can start contextualizing it. So, the ultimate goal here, I still remember I had an IIoT manager for a very large electronics company. He said, Arlen, I want to be able to walk into my factory with my laptop and with proper permission, plug into the network and learn the factory in 10 seconds. And that's where we should be able to get to. In some cases, we can do that, but that's going to be the future. Is we're going to quit talking about OT-IT convergence, and we're just going to use the equipment.
Good point. And from your perspective?
I mean, I kind of allude to the Lego model a little bit, where, depending on where you are on your journey, you may be building an expert model. You may just still be in, the simple 3 to 5 year age, building blocks, but the ability to continue to stack on and build and integrate more parts of our operations and lean on what technology is bringing us to continue to build kind of some of these amazing constructions of artwork that people are doing with Legos. I feel like that's kind of what we're looking at here with how it's going to evolve. And it gives each company, the ability to build at their own pace. But I would say if you're not building, you're going to get left behind. So
it's certainly speeding up in the past couple of years. And again, I think what's fascinating is that, my own personal opinion, most companies won't end up with one digital twin where everything feeds in. They might have multiple digital twins for different use cases, but once they start to then kind of merge that data together with other platforms, you start getting people looking at data in different ways. You're breaking down the silos. So the business folks are starting to look at things, and then they'll say, oh, well, what if this, and can I simulate that, and whatever. I think that's where we're headed as well, but it's breaking down a lot of the organizational boundaries, which is interesting. Right, 2 last questions, and anyone can start. Where do us people fit in with all this? John, you mentioned we'll have LLMs and we'll have Gen AI, and God, I can retire. The digital twin will look after itself. Where do people fit into all this?
I think the institutional knowledge. Computers they're dumb. They're as good as the data that goes in and the algorithm that's written on them to generate the data that comes out. The guy who knows if I go over and twist the valve 10 degrees to the right, then it's going to fix this problem. That knowledge, it's very hard to take that knowledge into a computer. That's kind of machine learning, artificial intelligence, but I don't think that's going to disappear anytime soon. I think we're going to need people to make decisions.
It is all about people and processes. So we can put all of this together if the organization, and we have organizations, they have the same equipment in the field, they have the same edge compute, they have the same cloud infrastructure they're going to, but some are getting it because their people are working together. There is no friction between IT and OT. To Ann's point, they sit down, they go, we're going to sit down, we're going to map out a flow computer, by gosh, until the business don't have to be a flow computer expert to understand what's coming up. So it is all about people and process. You can have the most fantastic technology, and if we can't get rid of some of the barriers that are out there just from a historic standpoint, we'll be talking about this 10 years from now.
True.
And I think that the change management element of implementing digital twins and across the board technology is probably the hardest piece of all of the implementation combined, just because, people are people and we all work differently. But at the end of the day, bringing the right people together and moving them along. And I think it's kind of the crawl, walk, run mentality. We can't expect someone to run a marathon tomorrow with no training and that hasn't ever been able to walk. So we've got to drive that education and that change management. But I think really what the technology is bringing is a game changer for our people. But if they're not embracing it and using it, then it's as good as not being there.
No, agreed. Now, we're not going to get to all the questions, but I know there was one, what's the difference between digital twin and metaverse? If you look at the next generations coming out, they're all playing 3D games. 3D models are kind of just the world they live in. People are off creating their own games and whatever in Fortnite and. So, my own personal thing, metaverse is kind of all these, what would you say? All these technologies coming together. The digital twin is a building block of whatever metaverse you want, whether it's your company's metaverse or your climate metaverse or whatever. It'll be built up of digital twins, but it's fascinating. Right, we're coming up against the clock. So let me do this. If I was to ask you, if there was one thing people should take away from this session today, what would that be? Let me start with Anne.
I would say act now and don't be afraid to use digital twins.
John?
Yeah, I think the main takeaway is this technology exists. You've talked about NVIDIA Omniverse a few times, and we heavily use that technology. That is a huge toolkit to do anything you can think of. Particle flow simulation, fluid flow simulation, physics-based simulations, robot simulations, on and on and on and on. This technology is out there. It is now accessible, and it's probably a lot further along than a lot of people realize.
And Arlen?
There's a lot of technology. I agree with John, but my best advice is don't eat the elephant. And we see way too many people getting so far into that, it becomes analysis paralysis. Find one problem, take some of the technology that we've talked about today, solve it, and then take the next step. I like Ann, crawl, walk, or run. But I see way too many companies trying to eat the elephant way before the elephant's ready to eat.
Eat the elephant in small bites.
Exactly.
Folks, I'm afraid we're up against the clock. We could, you could have we'd have a Netflix series and all this stuff for months. You'll see a session evaluation coming up. Obviously, we were brilliant, so lots of fives. But I would like to thank Anne, John, and Arlen, especially Cirrus Link, for sponsoring this session. Folks, we'll try and get back to some of the questions that we didn't get to. Feel free to reach out to any of us on LinkedIn or through IIoT World, and we'll get back to you. But with that, thank you so much, folks.